Similarly, for the receiver, we also introduce three terms: receiving window size, which is short for RWS, the largest acceptable frame, LAF, the last frame received, LFR. And the relationship between them represented by this diagram we mentioned many times. So the relationship between them, if using the equation represent, will be this value minus this value should be within the capacity of the receiver, which represented by the window size RWS. And based on this relationship, I'm able to, or I can model the decision making of the receiver. Basically, if they receive the frame with a sequence number within the range LFR and LAF, they will accept this frame, and then they will decide whether they need to send out the ACK acknowledgement. Okay, so that is determined by the sequence number to acknowledgement. Basically, this one is represented with or represents the largest sequence number which receive but not send acknowledgement. Again, in other words, in this protocol, the acknowledgement is the cumulative. So what that means is this value is represent the package up to this way. So basically, if you receive the acknowledgement 5, that means the receiver already received the frame up to the index 5. Okay, so if you say acknowledgement 10, that means you already received the frame 10 and out frame before that. That is called cumulative. Okay, so and then we can, based on this idea, we can keep update this LFR by using this sequence number to acknowledgement, because that is the most updated information about the packet received. And then after updating LFR, I can update LAF by using the LFR and the predetermined window size. And then here, just say how you select the window size. For example, the receiver window size and the sender window size. Sender window size in order to fully take advantage of the networking resources. We can try to keep the pipe full, right? In order to keep the pipe full, basically I want to set this window size exactly equal to the capacity of this networking infrastructure we focus on, which is equal to the delay times bandwidth. Okay, and for the receiver sides, I just want to explain one more time. What this means although you need to take a full while the RTT time to receive the first ACK is fine, because during the time you receive one new ACK acknowledgement, you still can keep sending the packet to make sure all the packet will occupy fully the network infrastructure. That is the whole meaning of the Windows sender window size is equal to delay times bandwidth. Okay, so now we talk about receiver window size. You can do two things, two extreme situations. The first is receiver window size is 1. What does this mean? Means you does not have any buffer for the receiver. The receiver will not store the any package as long as receive the package. They'll either decide to discard that or receive that and then send the ACK. Or you can think it's the RWS equal to SWS, means the buffer or the capacity of the receiver same as the capacity of the sender. So basically the receiver will buffer all the frames they send from the sender before sending the acknowledgement. Okay. So the one thing is I want to ask whether it makes sense to thinking another case is the receiver window size larger than the sender window size. Here, actually, I already gave you the conclusion that does make sense. I want to ask why. Please pause here to think a little bit to answer this question. Yeah, the answer is no. It does not make sense. Why? Because the receiver, the maximum number of frame it can receive for the receiver is equal to the one sent out from the sender, right? You cannot receive more package than the sender send. Just like, right, I give you apple, right? You cannot have more apples than I give you, right? The maximumly is you not eat any apple yet, so you have what the number of apples in your hand is same as the one I give you. That is why it just doesn't make sense in this situation, because you cannot have more than the frames run. Okay, so basically here it's impossible for more than the sender Windows frame to arrive out of order, right? What means out of order? Means out of frame actually buffer in the receiver. It is the out of order one. If it's not out of order one, for example, in private example, the frame 6 does not receive, but the frame 7 and 8 receive. If it's not that the case, you can just keep sending the acknowledgement to not to buffer that, right? Okay. So here, just give one example. So that example basically is we consider the case is the sender window size and the receiver window size the same, both equal to 3. Okay. So now I say assume the timeout interval predetermined is 2 RTT. Okay. So I want you first draw the timeline and diagram to representing situation as the following, which is the frame 4 is lost. How you draw that? I suggest you pause here to draw by yourself and then compare with the solution I have here. So just to save some time, I will not draw that by myself, but it's similar to the one I demonstrated before, but I just prepare that in advance. So basically what this means is you allowed to send, what means the sender window size means you allowed to send so many frames before you receive the first acknowledgement, right? So basically I am allowed to send 3 frames before we receive the first acknowledgement. After that, after we receive the first acknowledgement, I continue to send another 3 frames beginning from frame 4. But if you recall here in the scenario, frame 4 is not received successfully. So what I do is I will buffer the frame 5 and 6 in the receiver until the frame 4 successfully received. After doing that, I will send my cumulative acknowledgement, which is acknowledgement 6. Recall, after doing that, I will update my here the LFR, right, which equal to from beginning from 1, now it's equal to before it's I think it's 3. Let me see. Before it's 3, now it's updated to 4. Yeah, and updated to 4. Okay. Well, let me see one more time. Before it's 3, and then now updated to 6. The reason is 5 and 6 already buffered. Let me see one more time. So basically, here is give the sender window size is equal to receiver window size equal to 3. So that means you will you are able to send 3 frames before receiving the acknowledgement of the first frame, right? And then you will send another 3 frames, okay? And then the thing is the frame 4 is not received successfully, lost, right, in this scenario, but frame 5 and 6 are received successfully. So what the receiver do is it will buffer frame 5 and 6 and wait until frame 4 receives successfully, like here. They will send out a cumulative acknowledgement is acknowledgement associated with the sequence number to acknowledgement 6. Okay.